Welcome to the Explainer. Today, we're taking a really detailed guide and boiling it down into a super fast 5-minute build. We're going to tackle a classic problem. How do you store literally any kind of file? We're talking images, videos, docs, you name it, all in one database using MuleSoft.
Okay, so let's get real. You've got all these different file types, JPEGs, PDFs, MP4s. How in the world do you save and retrieve them all reliably from one single place? It seems like a huge headache, right? Well, the solution we're about to build is actually surprisingly elegant.
So here's the plan. We're going to build a MuleSoft API that acts like a digital librarian. You can hand it any file and it'll know exactly where to put it in our MySQL database. Then, whenever you need it back, it'll fetch it for you in a snap. Let's see how it's done. All right, any good project starts with the right toolkit. To pull this off, we really only need 3 key pieces of software. First up, MuleSoft. This is going to be the brains of our entire operation. It's an integration platform, which is just a fancy way of saying it'll handle all the heavy lifting, taking in the file, talking to the database, and wrapping it all up in a simple, clean API. Next, all those files need a home. For that, we're using MySQL. It's a super reliable and popular database that's going to act as our secure, universal library for every single file we throw at it. And finally, how do we know if our creation actually works? Well, that's where Postman comes in. It's a fantastic tool that lets us pretend to be a user. We can send files to our API, ask for them back, and make sure everything is running perfectly. Okay, we've got our tools. Now it's time to prep the workspace. Trust me, a little bit of groundwork here is going to make the rest of the build go so much smoother. Getting this foundation right is everything. It's just 4 simple steps. First, we'll get the database ready. Then, create our Mule project, add a few essential building blocks, and finally, connect the two together. Easy enough. So, first things first, the database. Once you have your account set up, the most important step is creating a specific table. We'll call it file info, and it's going to have columns for the file's name, its type, and, this is the magic part, the actual file content, stored as what's called binary data. Next up, inside our Mule project, there's a file called pom.xml. Think of it as a list of ingredients. We just need to add a few key dependencies. These are like little power-ups that give our API special abilities. One to handle web requests, another to talk to databases, and a special driver just for MySQL. Now we just need to introduce MuleSoft to our database. Inside the project, we'll set up the database connector with our server info, the host, port, username, and password. This creates a kind of digital handshake, allowing our app to talk directly and securely to our MySQL server. Okay, the foundation is solid. Now for the really fun part. Let's build the core logic of the API, the part that's actually going to do all the work. Our API is going to be really simple. It's going to have 2 main functions, or what we call endpoints. We'll have a post endpoint at a path called /postdata, that's for sending files to the database, and we'll have a get endpoint at /betData for asking for files from the database. That's it, simple and clean. So how does it all kick off? Well, it starts with an HTTP listener. You can literally picture this as an open door on our server. It's just sitting there, listening on port 8081, waiting for someone to show up at the /postdata path and hand it a file. The second that listener gets a file, it immediately hands it off to the database connector. This component then runs a quick SQL query that takes the file's name, its type, and its raw content and neatly inserts it right into that file info table we created earlier. Now, getting the file back is pretty much the same process, just in reverse. When a request comes in to our /getData path, the database connector goes and finds the file, grabs its content, and passes it over to a file connector, which then writes the original file right back onto our computer. And believe it or not, that's it. The build is done. The logic is all wired up, the connections are made, so let's fire up Postman and see if this thing actually works. Time for a test flight. Testing the upload is super simple. In Postman, we just set the request type to post, point it to our API's URL, and then attach whatever file we want to upload in the body of the request. Then, we just click send. And success! A 201 created response. That is exactly what you want to see. It's our API giving us a thumbs up, confirming that it got the file and has safely tucked it away in our database. Okay, so storing it is one thing, but can we get it back? Let's find out. We'll set up another request in Postman, this time a simple GET request pointed at our /getData endpoint, and see what happens.
Perfect, a 200 OK response. This tells us everything worked. The API found the file, fetched the data, and wrote the original uncorrupted file right back onto our system. The round trip is officially complete.
So, let's just take a step back. After all that, what's the big takeaway from this little 5-minute build? What have we really accomplished here?
Here's the most crucial part. This is so much more than just a single API. What you have now is a powerful, flexible, and reusable pattern for managing all kinds of digital assets. This is a foundational technique you can adapt for countless other projects. You know, this simple API is the fundamental building block for so many bigger ideas. Content management systems, digital archives, media platforms, you name it. Which really leaves us with just one final, very exciting question to think about. Now that you can do this, what are you going to build next?